Dr. Beckmen has been in Alaska since 1994 when she came up to do a PhD in wildlife management at the University of Alaska Fairbanks. She was the first wildlife veterinary medicine resident at UAF, where she trained and specialized in muskox and caribou diseases, treatment, and handling at the Large Animal Research Station, or LARS. She became our first state wildlife health veterinarian in 2004 and is focused primarily on caribou, moose, and other big game herd health issues. She has peered inside of more than 300 caribou while working for ADF&G, has co-authored numerous peer-reviewed articles and book chapters about caribou, and is recognized internationally as an expert on caribou anesthesia, pathology, parasites, and diseases. I've been lucky to collaborate with Dr. Beckmen on producing some wildlife health and disease field guides, and she'll talk a little bit more about our upcoming caribou guide coming out this summer. I learned a ton from working on the guides, and I tend to learn something new every time she gives a presentation. So with that, I'll hand it over to her. Dr. Beckmen.
So tonight, I'm going to take you on a look at some infectious diseases that affect and impact caribou populations. I'm not going to give you a litany or a survey of all the common diseases of parasites. We've got that really well covered, as Jen said. We've got a website and an upcoming pocket guide. If you want to find out about a particular disease or lesion that you might see in your caribou, you just go to alaska.gov and search in the search bar here. Just put in parasites and disease. It'll take you to this web page, and then you can click either on the information by the host or the list of diseases, and you'll come up with this list, and you can click on the particular common name of the disease, and you'll get something like this. This is cystic hydatid disease, and it gives you all the FAQs about a little summary about the disease. We also have some handouts, one-pagers like this one, which is on things that people frequently will see in their game meat. And I see that we've got a lot of hunters here tonight. So this is for you guys. This is the things that people report they see in their game meat, and they want to know if it's okay to eat it. And these are all very, very common, and none of these have any great consequence to caribou health, so we're not going to be covering these in detail. But I do want to point out these tapeworm cysts in the muscle and the heart. They don't affect the caribou, but they are in probably 50 to 70% of the animals. I would say actually probably closer to 100% of adults, and they don't harm the caribou, and people are not susceptible. We also have a one-pager handout on what dogs can get from game meat. And so that's also on the website. Again, none of these are ones that affect caribou populations, except for one that I'm going to talk about tonight, which is brucellosis, which is down here. So coming this summer, we're going to be printing out a pocket guide for caribou that we did a similar one for moose last year. And after all those gross pictures you just saw, I want to reassure you that despite all the talk of parasites and diseases we're going to go through, caribou are still very nutritional and healthy foods for us. And I have hunted caribou, and I eat caribou whenever I can, but I still see parasites in every animal I butcher. I just cook the meat as if I would do with any beef or pork that I got at the grocery store, because those all have things in them too. So caribou are still good to eat, but with your permission, what I'm going to do tonight is use this forum to talk about infectious diseases that impact caribou populations and how they impact those populations. I'm drawing from my 27 years of experience working on caribou, both alive and dead, and from this book that I don't get any kickbacks on this book. I did contribute to the chapter on anesthesia, but it's a book I recommend for any biologists or veterinarians or reindeer herders or people that are interested in depth about caribou diseases. And I'm going to adapt from this chapter for my talk tonight. So I'm going to start by defining disease, because not every time there's a parasite in an animal is it going to cause disease. The most basic definition of disease is a deviation from health, but that's really too simplistic. Disease is an impairment that interferes with or modifies the performance of normal functions. And this is typically things like energy utilization. And that could be something that impacts foraging behavior, assimilation of nutrients, or the cost of thermal regulation. So disease is actually a relative state. It goes a continuum from absolute health all the way down to death. The next basic concept is that the mere presence of a pathogen or a parasite does not equate disease. Disease causation is often described by the epidemiological triad, because there are factors of the agent itself, that pathogen or parasite, such as its pathogenicity, which is its ability to cause disease, and the infectious dose that's present. There are also environmental factors such as the immune function of the host, the nutritional reproductive state, and then there are environmental factors that affect the population, the pathogen survival in the environment, as well as the health of the host. Now that triad was very simplistic, a way to look at maybe a single parasite on a specific individual, and it's never that simple. There are many direct and indirect impacts of infectious diseases and agents on individuals and population, and these all can interact with each other. The infectious agents can directly affect survival, fecundity, which is reproduction and recruitment, body condition, and behavior. And then these factors interact with climate, predators, and disturbance, as well as co-infections with other diseases. And it affects individual animal fitness. And then this can lead to an outcome of either a growing, declining, or a stable population. So let's look in depth at some examples of these 4 ways that infectious diseases can impact caribou populations. One of the most complicated, but also one of the best documented that we're going to start with is the stomach worm, Ostertagia ruhineri. The hair-like worms you see in the picture of the Petri dish are the adult worms from a caribou that's been in every caribou that you've harvested, but you've never seen them because it's in the stomach. And the other photo is a lining of the stomach, and these little white raised bumps are actually the larval parasite. So these parasites, it's a roundworm, and it overwinters in the soil as well as in the abomasum of the caribou. And the abomasum is the gastric stomach. So it's that last chamber of the 4 chambers of the caribou stomach where digestion actually occurs. It's most like our stomach where the acid is. This photograph is the lining of the stomach severely infected with these larvae. And this microscopic picture shows some larvae in a gland in a cross section magnified many, many times. When these larvae burst out in February and March, it damages the glands in the stomach, and that makes the pH go up. So the caribou gets heartburn and diarrhea and does not feel well and can't digest food very well because it doesn't have the right pH, doesn't have the acid in there. And then the caribou loses body condition. And then this loss of body condition has a trickle-down effect on the animal and the population. The other important points of this life cycle are that the eggs are shed in the feces, and then the larvae hatch out of those eggs and contaminate the environment. These larvae can survive freezing and will infect the caribou that migrate back to this area the next spring and summer for grazing. There's that other stage of larvae that are penetrating the stomach again and spend the winter there. So this parasite has 2 ways to survive the winter. And especially with climate warming, those larvae in the soil can survive even more at higher rates. The impact of this parasite was well documented in a study of Svalbard reindeer that were collared, and half were treated with an anthelminthic, which is a dewormer that was in a slow release bolus. They captured the deer a year later, and they found that the treated reindeer were significantly heavier, fatter, and had a higher probability of being pregnant than those that weren't given the dewormer. In addition, the calves of the treated cows were larger and had a better survival rate, and thus it resulted in an increased population growth. However, there was a delayed density-dependent negative effect. That increase in fecundity, more caribou, led to an increase in parasite abundance and more environmental contamination with the larvae and higher burdens of the parasite in individuals. That in turn led to poor body condition and a decrease in calf production. And there have been studies in Canada and Greenland that similarly associated these stomach worms and other species of worms with lower body condition, body fat, and pregnancy in caribou. So at ADF&G, we attempted to determine if this parasite may have been a factor in the decline of the northern Alaska peninsula herd back in the late 90s and early 2000s. We collared calves and did a mortality study, and we also did a herd health assessment. And in a herd health assessment, we collect adult caribou at random, and we do a thorough in-depth examination of the blood and all the tissues for pathogens and parasites and monitor other health indices. These studies showed us that the herd, this northern Alaska peninsula herd, had a lower body condition and trace mineral imbalances and higher parasite loads, as well as predation rates compared to a healthy growing population, the Western Arctic herd at that time. So we went out and collared 50 adult cows and planned to recapture them and monitor them over 2 years. And we did see a modest increase in body condition in the 42 cows that survived that first winter, which is not a very good survival rate. However, predation took such a great toll on their calves. And only 3 out of the 40 calves survived until August. And that meant that we could not demonstrate any kind of statistical significance in overwinter survival or body condition of the calves, since they didn't even survive to the following spring. So Svalbard doesn't have any predators, and there weren't any competing ungulates. So our situation wasn't very similar, and we couldn't repeat those results. And we had the further complication of the problem of trace mineral imbalance in this population. Now, trace minerals are an essential element for life, just like vitamins, and the body tries to keep them in balance in the body, called homeostasis. And how much of a trace element is in the forage is dependent on the geology of the area, as well as factors that can vary from season to season and year to year, such as the weather, the soil pH, and rainfall, as well as the plant type and how the plant is growing. The absorption and assimilation of these trace elements, such as copper, the caribou ingest, is complicated by excess of other trace minerals. So within a caribou, having too much iron, too much zinc, or too much molybdenum in the diet can all lead to less availability of the copper. And if there's low copper in the diet, especially if there's high molybdenum, this leads to a direct copper deficiency. And copper deficiency begets a lowered resistance to parasites. In addition, Ostertagia, that roundworm we're talking about, decreases the assimilation of copper because of the way it damages the stomach. And this further decreases the caribou's resistance to parasite and increases the parasite burden. So it's very complicated, all these compounding factors. Now, another parasite that is common in Alaska, especially in our northern herds, and more increasingly, we're getting reports in the 40-mile herd and intermittently in Nelchina animals, that impacts body condition are warble flies. Now, warble flies are an obligate parasite of caribou, and the caribou are the intermediate host of the larval stage. So let's start where the adult fly lays eggs on the legs and flanks of the caribou. These eggs hatch and the larvae burrow into the skin and migrate underneath to the skin underneath the back, under the skin over the back. These larvae insist, meaning the caribou reacts just a little bit and forms a little capsule around the larvae. And the larvae actually chews a hole out of the skin so it can breathe. And through that hole in the spring, the larvae will exit and fall to the ground, and they pupate. They hatch out of the pupa into adults, and then the adult flies go back and harass the caribou, and the caribou, move to try to get away from these flies. Now, the warbles can have multiple impacts on the caribou. We recognize that the adult flies can cause panic and energy loss trying to escape from them, which affects their migration and feeding patterns. But also a study in reindeer showed that by treating them in the fall with an anthelmintic, again, a dewormer, the next summer, the female reindeer had higher body mass, and the treated cow's calves had increased early summer body mass. So this suggests that the development of the larvae have a direct effect on body condition that compounds the disruptive activity of the caribou trying to avoid the flies. Now, a few warbles might not be terribly significant to an individual, but if that individual is already weakened, then the impact of these warbles can be additive. And since warbles can also impact immune function, and those holes they make in the skin allow bacterial infections to get in and take off, they could indirectly cause mortality. And in a severe infestation, such as in this picture, the warbles are also taking energy away from the caribou. And it has been shown in reindeer that those heavy infestations are leading to poor body condition, and again, animals are less likely to be pregnant. So now let's look at some infectious agents that impact fecundity. Again, fecundity is reproduction and recruitment into the breeding population. I'm going to focus on a bacteria, Brucella, but I want to make sure I mention there are other parasites, protozoal parasites that you can't see that can also impact caribou reproduction, specifically Neospora caninum and Toxoplasma gondii. And we don't really see much toxoplasma in our caribou, but we do see 10% of the caribou positive for Neospora. And I don't have time to go into those in depth, but they are on the website. So these organisms that are affecting reproduction are silent killers. And we call them that because all the managers see that are monitoring the caribou populations might be just a poor calving success or a lack of recruitment. And these pathogens can affect the productivity of the population directly or indirectly, or both. The direct impacts are through damaging the reproductive organs, such as the testicles and uterus, so that fertilization and pregnancy don't occur, or fetal death, so that few offspring are born. The indirect effects can often be misinterpreted by the secondary predation that occurs when calves are born weak because of these infections, and when the neonates die and their carcasses are scavenged so quickly they're never seen. The disease that has all of these effects is brucellosis. Now, rangiferine brucellosis is caused by a bacteria, Brucellosis biovar 4, that is specific to caribou and reindeer. It's different than the brucellosis of cattle, elk, and bison that's in the Yellowstone ecosystem, but it has some similarities. It is mainly transmitted through the aborted fetal materials, but it can also be transmitted to the fetus when it's in utero and during mating. The effects on the caribou are the ones we just talked about: reduced fecundity, reduced reproductive success. That happens because there's abortions, lower calf survival, because the calves are born weak. There are retained placentas, and there is sterility in both bulls and cows. To compound this, the infection can impair the caribou's health and increase its susceptibility to other pathogens, another indirect effect. And it causes lameness that causes an increase in susceptibility to predation, which is an indirect effect on mortality. So the signs of this disease in caribou are typically manifest before and during the calving period. So in a maiden heifer, that's a newly infected caribou that's pregnant for the first time, gets exposed to bacteria, she will abort her fetus a month or two before the normal calving period. When the herd is newly infected or a large number of newly susceptible animals are pregnant, this can cause what we call an abortion storm. Besides abortion, there can be stillbirths, weak calves with low survival. And these are often hidden by predation and scavenging. And that abortion storm might not be recognized either because it doesn't happen on the calving ground. It happens before the calving ground, and nobody is out there looking at these animals in February and March. The aborted cows can have excessive bleeding after calving and have retained placentas. And this causes an infection in the uterus called metritis, which decreases their future fertility and can make them permanently sterile. The external sign of brucellosis that's most often recognized in caribou are these hygromas, which are swelling on the top of the carpus, which is the front knee that people refer to in a caribou. It's caused by a bursitis, which is an inflammation of the joint capsule. And it's a very discrete encapsulated swelling with a thick wall because it's actually the joint capsule. And it's filled with a thin straw-colored fluid that's odorless. It's very distinctly different from the yellow-green, thick, pussy abscesses that we see all the time in other areas of the body. But if you see this swelling, you absolutely do not want to cut into it because it is filled with these bacteria. The other sign that's seen in adult caribou is a swollen scrotum, as in this bull in the photograph. This is an inflammation of the testicle called orchitis and the epididymitis. This can cause them to become sterile, but more importantly, it is a way the bull can spread the bacterial disease to other cows during mating. And there will be reduced pregnancy rates if a number of bulls become sterile. And this direct impact on fecundity with a major consequence for the population dynamics has been documented in this case of Canadian caribou herd on Southampton Island. The increases in antibody prevalence, which indicates the exposure and an immune response to infection, is indicated by the red lines and circles. And it mirrors directly the decrease in pregnancy rate. So when the Brucella antibodies rose in the bloodstream, the pregnancy rate plummeted and they mirrored each other. And then the population abundance, which is this very light gray triangles, was coming up when the pregnancy rates went down, the population went down. So you're probably wondering, well, has this happened in Alaska? And it has happened. So I would have to say yes. So in Alaska, we have some historic evidence of a similar decline in the Western Arctic and Tehuantepec herds back in the 1960s and 70s. At that point, they were just called the Arctic herd. And I'll go back even further to say that Rangiferine brucellosis is thought to have been introduced with reindeer from Siberia in and around the 1902, 1906. In the late 50s, the first connection was made between this disease in native Alaskans and caribou, and this connection was made epidemiologically. And then it was in 1962 that the seroprevalence in the Arctic herd was 30%, which is extremely high, and 5% of the females surveyed, they were doing aerial surveys, had retained placentas. And as I mentioned, this is a sign of brucellosis. By comparison, the Nelchina herd at the same time that was being monitored had a seroprevalence, that's the antibodies, of 6.5% of the animals. The next year, the Arctic herd had a seroprevalence that was still very high, and 25% of the cows that had retained placentas or bleeding had lost their calves. By 1965, the seroprevalence in the Arctic herd had decreased by half, and the placental retention had also decreased. These declined during the 66-67 calving period. However, in 1968, 57.5% of the calves suffered mortality, and this was compounded by some very severe bad weather. This was followed by a precipitous population decline and a crash in 1970. After the population reached its lowest point, the reduced population density on the calving ground meant that there were lower numbers of susceptible caribou being exposed to the bacteria during their first pregnancy, and the placental retention rate declined below 1%. So because of the seriousness of this infection and its effect on caribou populations, ADF&G has continually monitored herds specifically for signs of this disease. So you may have heard about the recent detection of a high seroprevalence of Brucella antibodies in samples from the Mulchatna caribou, and wonder if this is the cause of the decline recently of that herd. And we don't know for sure. We do have some circumstantial evidence. We did a herd health assessment back in 2007, and this is back in the time I was talking about the Northern Alaska Peninsula herd we had just been working on at the same time. So we compared the Mulchatna herd to the Western Arctic herd and the Northern Alaska Peninsula herd to investigate disease components that might have caused that decline, although it was suspected at the time that maybe there was an overharvest of bulls. The most significant difference we found in the Mulchatna herd compared to the Western Arctic herd when we looked at these different health parameters and serology was that the Mulchatna had low trace minerals, including copper, high parasite loads, and some viral exposure, which were quite similar to the Northern Alaska Peninsula. So remember, I was telling you about how copper can affect parasite resistance and parasite loads, and viral exposure all were signs that there's probably an issue with the immune function in this herd. But there was no Brucella, and we looked for that. So we had been doing some pretty extensive monitoring over time, but we typically only take blood samples to analyze from the animals that are being radio collared. And typically those are short yearlings. That's what we call the 9 to 11, or excuse me, the 10 to 11 month olds that are being collared in the spring to get a handle on population size and pregnancy rates. So this is not the ideal population to monitor for Brucella because they don't have antibodies because they haven't been exposed to it. So we didn't have a lot of adult serum to test on this herd, but we can only say now that Brucella is present in this herd in 2015. And that's because there was a person who was detected, diagnosed with this disease at the Bethel Clinic, and they found that the organism was present in caribou that she had consumed. So we really didn't recognize the magnitude of this infection until we ran some tests on adult female serum from these adults that were collared in October of 2020. And we didn't receive those results until December, and that indicated a high exposure rate in the herd. And so we went back and looked at previous adult serum that was frozen in our serum bank, and it revealed that there was actually a high seropositive rate in bulls that were captured in 2015. So we don't even have the types of data that would be needed to determine the significance of Brucella to this herd decline, but the biologists that are studying the herd are developing plans to monitor Brucella. and a host of other factors to examine the impacts of Brucella on this herd as hopefully it recovers. So all we know is we've detected it's present there and there's a high exposure, but we don't know what the impact is on the population's decline, but it probably is a factor. Whether it's the only factor, it's probably not. Now, I mentioned the woman in Bethel getting Brucella from the caribou. So it's important to know that this is not only a problem as a disease in caribou, but it's transmissible to people. Diseases that people can get from animals are called zoonoses. So this is a zoonotic disease. And since people are susceptible, even though it's treatable, it is very serious. So I want to emphasize the simple steps you can take as a hunter to prevent yourself and your family from contracting this disease. It is very rare, but it's mostly rarely diagnosed, and we don't know how many people actually get exposed to it. The number one way to prevent from getting this infection from a caribou, because you won't know if the caribou is infected because you can't see it, is to use good meat hygiene. And that's to wear gloves when you're butchering and when you're preparing the meat. When you are butchering or necropsying caribou, do not open the uterus and don't handle the fetus. Don't ever open abscesses or swellings, especially on the leg, because that can contaminate the meat and increase your risk of exposure. If you do cut yourself, make sure you clean out the wound and flush it immediately. If you splash fluid from one of these, if you accidentally open the knee or open an abscess and it gets in your face, be sure to flush out your eyes, mouth, and nose with water. And then after butchering or preparing meat, be sure to wash the hands and knives with hot soapy water, the cutting boards and everything else. And then be sure to cook all the game meat to 160 degrees Fahrenheit. The thing that was most implicated early on for transmission of Brucella to people was actually from eating raw bone marrow. So by cooking the meat, it will kill the bacteria. The bacteria is resistant to freezing. So actually we freeze tissue to preserve the bacteria and then we culture it later. So freezing, drying, smoking doesn't kill this bacteria. It really must be cooked. So now let's look at a parasite that causes an impact of on behavior of the herd and can have a population impact. And these are the ostrid flies. And the ostrid fly larvae is known as a nasal bot. So that's where it gets its name. And these flies deposit their larvae right into the nose of the caribou. And then the larvae migrate, they wriggle their way up the nasal passages into the pharyngeal pouch in the back of the throat, where they develop into this wriggling mass. And you probably won't see these unless you are cutting off the head. And when you take out the tongue, you accidentally cut into this pouch, and then you'll see these things come oozing out. The caribou will sneeze these larvae out onto the ground, and then it pupates. So that's what it looks like. The pupa then will hatch out into an adult. And these adult flies terrify the caribou when they come at the caribou and to lay their egg, lay the larvae in the nose. So they're even more so than those warble flies or mosquitoes. These are the insects that are driving the caribou to move to places to avoid flies. And it's those female nasal bot flies zooming in towards the nose to strike that terrifies the caribou and can cause them to run, which uses energy, and they will go to areas to avoid flies. And these areas, you know, they could be on the coast or someplace where it's very windy. It might not be a very good place to forage. And so this avoiding the fly strike changes the behavior and causes them to waste energy avoiding the flies or hanging out in areas without good forage. And this affects their feeding behavior. So they spend less time feeding because they're trying to avoid these flies. They don't rest as much. When the flies are around, they are stomping their legs, dropping their head, and they're running. So they're wasting energy. And the larvae are also irritating, and they cause mucus production, so they can cause the animals to cough and sneeze a little bit. But that's not as severe as the behavioral aspects. So there are those direct energetic costs to the movements of the caribou and the lack of rest and spending less time feeding. And so the animals fail to fatten up, especially for the rut. So there's this indirect cost because this decrease in fatness, we know that decreased back fat is correlated with decreased pregnancy rate, decreased growth rates, and decreased overwinter survival. So the nasal bots can have a really severe impact on the population level. Now, there are other diseases and parasites that can impact survival directly or indirectly. And I'm just going to mention a few of the indirect ones here. So indirect mortality could be through an increase in predation risk. It's pretty easy to understand that a disease that causes lameness is going to make a caribou easier for a wolf to run down. And things like foot rot, which is that picture there, or brucellosis, which is causing the lameness in the leg, pretty easy to understand. But there are other more subtle things, and those examples might be things like respiratory viruses or parasites that impact the lungs so that the caribou are less fit and less able to escape. So I'm going to talk about one that's really common, and I'll close with this one. It's called cystic hydatid disease, and these are tapeworm cysts that are found in the lungs of caribou and moose. The adult worm is actually very, very tiny and found in the intestine of the wolf. The wolf sheds the eggs of the tapeworm in its feces, which contaminates the plants forage that the caribou feed on. So when the caribou inadvertently swallows the eggs, these hatch out in their gut, and the infective stage travels to the lungs and then sets up these cysts in the lungs. And the cysts are quite large. They're usually ping pong ball size, but it can be a bit larger. When the wolf kills the caribou and scavenges on the lungs, the cysts burst open, and inside are all these little baby tapeworms. Essentially, each one of those little flecks there is an inverted tapeworm head. And that goes into the wolf's mouth, and it swallows it, and it starts the cycle all over again. So if a caribou has a lot of cysts in its lungs, it may not be able to run as far or as fast, and thus it's easier prey for the wolf. And this enhances the parasite's transmission. So evolutionarily speaking, it's an advantage for the parasite to slow the caribou down, but not enough to kill it, so that the wolf will kill it and eat it really fresh and get these tapeworm cysts blowing out into its mouth. This particular parasite is killed by freezing, so the wolf has to eat it before it freezes. It is possible, but quite rare in Alaska, for a person to become infected from the eggs from fecal contamination from the wolf or from a dog, for example. This is why we recommend you do not feed moose lungs or caribou to your dog, because they could become infected with this parasite and shed the eggs, and you would be at risk. So it's easily avoided by washing your hands before you eat, or any time after handling wolf pelts or scat contaminated things, petting the dog. It's important to wash your hands before you eat. So I would love to go on and tell you about many more diseases, and I'm sure you're going to have some questions, but I would probably need a week of your time to tell you everything that I'd like to tell you. So I'm just going to wrap up with these few points. I want to remind you that the presence of parasites, bacteria, viruses are a normal part of the caribou's ecosystem. And it depends on many factors and various interactions that will determine the magnitude of the impact of an individual caribou's health and the potential significance of a disease to the population. There are some diseases and parasites that people can get from caribou, but they're easily avoided by not cutting into abnormal swellings, especially around joints, wearing gloves, washing hands and knives, and cutting boards. So even though these things are around, you can avoid them. And the advantages of eating caribou, it's a very healthy meat, far outweigh the risks if you just take those simple steps. And again, if you have any questions or you want to report seeing something unusual, or you don't know exactly what it is and you weren't able to find it on our website, you can email me at dfg.dwc.vet@alaska.gov. Pictures are great. It usually helps to have a picture. And you can email me about sending in something for us to look at. Again, our website at adfg.alaska.gov has a lot of information materials there. And I also put up the phone number there for our reporting message line. So you can text or call if you have an urgent question. And you can also text pictures to that number. And I'll just leave that up there for a second, or maybe I should unshare so we can have some questions.
Yeah, if you unshare, before we get in, we have some questions starting to formulate in the chat box. So before we get into questions, while I have everybody online right now, I'm going to share my screen real quickly and just go show you a couple of resources, and then we'll start answering questions. So soon, let me know when my screen shows up. Is my screen on?
Yep.
Okay. Okay, so just a couple things here. One, just want to show you that regarding caribou, we have a lot of other resources about caribou, newsletters, rack cards, a lot of web information. So these are all on our website. And I'm also going to show you how to find them on our database as well, our publication database. But while I have these slides up, I want to show you the next, our next presentation is on April 15th, and we're starting to do the individual herd updates. So if you're interested in a particular herd, right now we have Heidi Hatcher, the Glen Allen area biologist, is going to do a presentation update about the Nelchina caribou herd. And then on May 4th, Alec Hansen from out in Nome, researcher, is going to do an update on the Western Arctic caribou herd. And we may have some more herd updates coming, but we will keep posting those on social media. Now, if you want to find any of our publications about caribou or about anything, you go to this is our main page of our website. And we have a thing up here called e-library, and then publications. And if you just, this is the publication database that has everything in there. And if you want to do a search, I'll go to wildlife, because that's our division. And you can go to Wildlife Information Education Publications, and there'll be a database in there that you could search for. Search anything. If I just go just for a species, and I look for caribou, if I could find it easy. Put in caribou. There's a lot of forms that you can fill out here to really narrow your search. But if I just go caribou, all the caribou publications will come up in by the year, dating back. These are all kinds of different reports and publications and newsletters and field guides and everything that you can imagine on there. So that is there. The other thing that I want to point out, all of these recordings that we're doing, all the presentations we're doing are on our Alaska Department of Fish and Game YouTube channel. They're also on our Vimeo channel as well. But you can find them on our YouTube channel. This is the YouTube channel. You go to Wildlife Conservation and you can see all the videos listed in here. Cow and caribou, the one we just did last week. And it's not just caribou, there's all kinds of topics on there. So feel free to go to our YouTube channel and check that out. And I think that's about all that I have to cover. So I'm going to unshare and see if Jen has anything else for you, and then we can start answering questions.
No, I don't think I have anything else. I think we can get to questions. I first want to thank Dr. Beckman for her time this evening and for the presentation. And I think the first question that I saw was, how do we have records back to 1906 from when you mentioned it in your talk?
That was from actually the journals of Sheldon Jackson when he brought the reindeer over from Siberia for the Alaska natives because they were starving with the whalers had killed were killing all the whales. So that's actually from records from Sheldon Jackson.
Okay, Mike, you want to do the next one?
Yeah, sure. Is there anything that dogs can get, like the flies, for going with you? Okay, I'm not quite sure I understand that exactly.
Well, I see. Do canid carriers of the tapeworm parasite exhibit any symptoms? So no, the tapeworms in the lung, the one that's in the lungs of the caribou, when it's in the wolf, it's really tiny and there can be thousands of them and they don't have any effect. But the problem is that we could get that cyst in our body, so we don't want to get that. The other tapeworms that dogs can get from caribou are from the meat, and those are those little white blebs in the muscle that are really, really common. They call them measles, but they're just little tiny white blebs. I don't know what else to call them. They're extremely common in caribou and moose. And those, if a dog were to get them, they're a large tapeworm and they could take some energy away from the animal. So that's why I tell people you don't want to be feeding the tapeworms in your dog's gut with $60 a bag dog food. So you want to make sure you don't get your dogs infected with those tapeworms.
Okay, there's a couple questions about chronic wasting disease. Has it showed up in Alaska yet, and is it a threat?
Well, it's certainly a threat if it were to get into caribou. Caribou are susceptible, as far as it's been found in reindeer in Norway, so we know they can get it. We just haven't had any known introduction of CWD to Alaska. It's possible that it's in one of the captive herds of elk or something like that. So we're doing everything we can to prevent it from being introduced. And one of those key things is to not allow people to have pet deer or bring deer into Alaska or have farmed deer, because that would be a mechanism, and even importing any elk that could bring CWD to Alaska.
And just in case some people missed it in the chat, that you got a question about, can some parasites or diseases survive being cooked?
So everything that we have in Alaska that we know that caribou carry are killed by cooking. The tapeworm parasites are killed by freezing, but there are things in the meat that you can't see, like toxoplasmosis and Besnoidia and Sarcocystis and things like that. So you always want to cook the meat because you don't know if it's got Brucella or something like that. CWD is the one thing that is not killed by cooking, but we don't have CWD in our caribou, and that would be in the brain tissue anyway. So that's not a concern at this time. So just cooking will kill anything that is of concern to our health from eating caribou. But some of the things are not killed by drying and smoking, so you have to be careful with those.
Okay. Does anybody else have any other questions out there? Now's the time.
One other thing about from our publications person, that on the, you could also find technical reports as well on that site, the e-library that I showed you. I just didn't show you that menu on the left-hand side, so you can find all technical papers on there as well. There's a lot of biology type people out there I see tonight, so.
While we're giving everybody a moment to think, we have a poll for you guys on your way out, if you wouldn't mind answering that. And Dr. Beckman, something that stuck out to me was somebody said, maybe I don't want to eat caribou anymore. And my thought was, you know, moose have a lot of the same common parasites and things too, and so do lots of game meat. So I just thought maybe.
Yeah, and I tried to point that out at the beginning. Maybe they missed the first part, that I love to eat caribou. And I hunt caribou, and every caribou that I cut into, I will find a parasite within a minute, I can tell you. That doesn't stop me from eating. I have less fear of eating caribou than I do eating ground beef from a grocery store or pork from a grocery store. It's a lot healthier meat for you, and anything that you can't see can be cooked out of it. And the thing is, and when I eat caribou, I don't even really cook it that thoroughly. I eat it kind of medium rare. So, and I'm the one who's looking and knowing about all those things. And caribou is a good food, so I would not be afraid. You just don't know about all the things that are in cattle and pork.
All right, anybody else?
No more questions out there? You got the best person to ask a question to right now. So don't call the office tomorrow and ask. Because
yeah, I'm stuck home right now with the snow. So until they plow me out, I won't even be around the office.
I got a question here. Can you talk about how common brucella is in the Arctic caribou herds? She might have missed.
So I didn't talk about the level of it now. When we do, we look at antibodies in the blood of the caribou that are being radiocollared. It's really low numbers of animals that are positive. What we call the seroprevalence is about 2 to 4%. And that just means they've been exposed to it. It doesn't mean they currently have bacteria in their body that could infect you. It just means sometime in their last 10 years, they were exposed to it. So it's very, very low, but it's higher than we had seen in other herds like the Mulchatna or the Northern Alaska Peninsula, where we just had never detected it at all. And we see about one case where somebody turns in a swollen leg that turns out to be brucella from one of those northern herds about once every 5 to 10 years. So it's pretty uncommon.
okay. Yeah, this is a question again. I think we already answered it, but can all parasites and diseases be killed by being frozen? And the answer is no. You have to cook the meat in order to kill most of them, actually.
Yeah. The tapeworms are killed by freezing, but the bacteria are actually preserved. Either I wowed everybody, or I was so thorough that I've just covered the subject ad infinitum.
Okay, let's see. All right, that's a little more complicated one. It's something about the, exchange, the ability for the exchange of native and non-native livestock, or livestock and wildlife.
Well, it is the problem with like reindeer from the Seward Peninsula are infected with brucella. So by moving infected reindeer to other areas, and if they come in contact with caribou, they can spread brucella to caribou herds that aren't infected. So that is an issue. We don't have the cattle brucella in Alaska. Alaska is the bovine brucella free. That would be a problem, but cattle cannot be brought into Alaska without having a negative brucella test. So we try to make sure that the diseases are not transmitted from, say, reindeer to caribou. So to move a reindeer anywhere in the state, it has to have a negative brucella and TB test and have a permit from the Office of the State Veterinarian. So we are very concerned about brucella in reindeer being transmitted to caribou herds. So that's why they have to have a negative test.
Okay, hopefully, yeah, she was just meaning livestock, I guess, but hopefully that answered the question though. It doesn't really matter if it's just about livestock, because they can still have an effect or interaction with wild animals.
Two more. There's one that asks for a clarification of if there are any parasites that survive both freezing and fully cooking above 160 degrees Fahrenheit height.
Not that we know of, other than CWD, which is not present here in Alaska.
And then one more, are there any instances of human diseases being transmitted to caribou or other ungulates?
Well, I have to say that just recently an experiment that was done showed that white-tailed deer fawns are susceptible to SARS-CoV-2 virus. So it's possible that it happens, but we haven't recognized any cases in Alaska that I know of. I'm trying to think. There are certainly like human giardia has infected wildlife rather than the other way around. So there are some things that animals can get from us. And right now the concern for wildlife especially is whether SARS-CoV-2, the virus that causes COVID-19, can be transmitted to wildlife, because we know that mink can get it, and large cats and things like that. We don't know yet what all wildlife might be susceptible to that virus.
Okay, you might have to wait for the Nelchina herd update for this question, but how healthy is the Nelchina herd? So good luck with that one.
I have not conducted a herd health assessment of the Nelchina herd, so better to ask Heidi how things are going down there. There has not been a disease outbreak that I have been called in to investigate in the Nelchina herd.
Okay, we have another one. What effect is climate change, early breakup, earlier fly and mosquito infestations, etc., having on caribou?
Well, we do know that climate change is affecting parasites that are coming farther north and spreading, and we haven't seen those direct effects in Alaskan caribou yet, but they are detecting those in Canada, in muskox and caribou and in moose. So we know that this is a concern, because there are a number of parasites that weren't a problem here because of our cold And now with warming temperatures and changes in rainfall, that allows ticks to survive, and also makes the life cycle of certain lungworms go faster, so that they can go through 2 life cycles faster than they used to just do 1. So that increases infections. So we do expect to see the expansion and increase in a number of parasites because of climate change. And certainly if we get warm enough, and this isn't going to affect caribou, but for example, heartworm disease in dogs, the only reason we don't have heartworm transmission in Alaska has been because it's too cold. The summer is too short for the mosquitoes to go through enough life cycles to transmit heartworm, but we're getting above that now. So pretty soon, heartworm disease may become a problem in Alaska because the mosquitoes can survive long enough. The season is long enough. So the same thing could happen with mosquito-borne diseases that caribou can get. There are viruses and other parasites that are spread through to ungulates via mosquitoes. And if we get that, then we could have a problem with diseases like blue tongue and epizootic hemorrhagic disease and things like that.
Yeah, that question came up in our original Caribou Across Alaska, the whole original, and researchers are, there hasn't been enough time, or there isn't any research like making any connection to that right now, but so those are potentialities.
Yeah. And someone's asking about how many life cycles of mosquitoes are needed for heartworm. The mosquito has to live long enough for the larvae to go through 3 molts inside the mosquito. And so it's the length of the time that the mosquito is alive has not been sufficient enough for canine heartworm up until now. Well, this has been really great, and I appreciate everybody's attention and everybody signing up and all the participation, because I love talking about this stuff, and I hope I didn't turn everybody off of eating caribou meat, because it's good for you.
All right. Well, I don't know, Jen, what do you think?
You did, there's one more that popped up that said what causes CWD, but I don't know how relevant that is to caribou since we don't have it yet, but Dr. Beckman?
Very briefly, it's caused by a prion. So it's like mad cow disease, but in certain deer species. We could talk for hours just on that one topic.
Yeah.
And in Alaska, we're very lucky that we don't have it and we don't want it. And we need to keep it out.
Yeah.
All right, any last questions? If not, I think we're wrapping it up. So thank you everybody for your time and for joining us tonight.
Thanks. Bye.